Okay, this is the analytical geometry question 3 part of the 2022 grade 10 exam. Let's just give it a try. Paper 2, here we go. A point C has coordinates of 1 and minus 2, and D has coordinates of x and 5. The distance between them, CD, is root 53. Determine the value of x, and all you use is the distance formula, which says that the distance squared between any 2 points, all you do is subtract the x coordinates, x minus 1 squared, and subtract the y. 5 minus minus 2. There it is, 5 plus 2. That's 49. X minus 1 squared is x squared minus 2x plus 1. You have to be able to multiply out that x minus 1 squared. And root 53, that's what CD is squared, is 53. Well, I'm going to go 1 plus 49. I'm going to subtract 53. I'm going to get minus 53. I'm going to get minus 53. And then 50 minus 53 is minus 3. I left it on the right-hand side here, but I switched it around. But it's x squared minus 2x just stays there. You've got a 50. You take away 53, you get minus 3. Now you put two brackets. Minus 3 times 1 is minus 3, but minus 3x plus 1x is minus 2x. How important is it to factor? Because you get two answers here for x. X is 3 or minus 1. Okay, let's try the next question. We've got a diagram below, and there's points D, E, and F. D is 3 and 3. E is minus 3 and minus 5. F is 1 and K. Determine the length of DE. Well, it's just the distance formula again. 3 minus minus 3, it's 3 plus 3 squared. 3 minus minus 5, 3 plus 5 squared. Well, that's 6 squared is 36. 8 squared is 64. When you put it together, you get 100. Now, that's what DE squared is. You square root it, and you get DE equals 10. There's your answer. Then they ask you to calculate the gradient of DE. These should be like just about free marks, because of the gradient formula, and you've got it there, and the exam tells you to go 3 minus minus 5. y2 minus y1. 3 plus 5 is 8. 3 minus minus 5 is 3 plus 5, which is 8. 3 minus minus 3 is 6. And 8 over 6 is 4 over 3. The gradient of DE is 4 over 3. Now determine the value of K if this angle here is 90 degrees. Well, if that angle is 90 degrees, then the gradient of DE times the gradient of DF is minus 1. Why? Because if it's DE is perpendicular to EF, that's the reason. Well, now we can use this actual equation to figure it out. We've already worked out the gradient of DE. It's 4 over 3. But the gradient of EF is, let's subtract the y, K minus minus 5. That's the y guys subtracted over 1 minus minus 3, 1 plus 3 equals minus 1. Oh, look at this here. Well, now we just solve for K. Hey, that's pretty, we just about got it right there, because look at that 1 plus 3. It's the same as 4 here. And 4, if you're multiplying and dividing by it, it cancels. Then you take this 3, multiply it by negative 1, you get minus 3. Multiply both sides by 3. And then subtract 5 from both sides, and you get K is minus 8. And it's going to make you feel better in the next question that you've done it right, because they say if K is minus 8, determine the coordinates of M if K is minus 8. So we know that this is actually minus 8. The midpoint of DF, how are we going to find the midpoint of DF? Well, we know that F is 1 and minus 8. D is 3 and 3. All we do is add the x coordinates and divide by 2. 3 plus 1 divided by 2 is 2. There's the x coordinate of the midpoint of DF. Then we go 3 plus negative 8. That's negative 5 divided by 2. It's negative 5 halves, or negative 2.5. There's the midpoint. Last question. Determine the coordinates of G such that D, E, F, and some point out here, G, makes a rectangle. How are we going to do that? Well, you know, if we know that's 90 degrees, all we do is we look at D and look what's happened going from E to F. What's happened? Well, the y coordinate was at minus 5, And now it's at minus 5. And now the coordinate of the x-coordinate's gone down to minus 8. Well, that makes, I'd say, what would you say that makes? I'd say it's dropped 3. I don't know what I wrote down here, but it looks like it's dropped 3, doesn't it? So that should be minus 3. From minus 5 down to minus 8, that's a drop of 3. Let's just write 3 in there. I think that's what it is. It's 3. And then if we go 4 to the right from here, if we're at minus 3 and we go to 1, we've gone 4 to the right. Well, now, the way you do this is you just do the same thing up here. You just do exactly the same thing up here. And I think it's not going to give us that answer. Let's see here. We're trying to figure out this point here. We're calling G. Okay, we're going to try and figure out what G is here. And all we do is we're going to take this 3 and go 4 to the right. And I did have that part right. It is 7. It's 7. That's the x-coordinate. Here, we just do the same thing that's happened to E. Do the same thing with D. So we went 4 to the right. And how many? 3 down. 3 down from there. Hey, that's going to go to 0. I think it's 7 and 0. And there it is, all fixed up. I made a mistake in the first memo, but that looks like it, 7 and 0. Just go 3 down and 4 to the right to get your answer. Do the same thing that you would on either end, and you'll make a rectangle.